Hello, my name is Chris Muller and my partner is Dominic Rollins, and we are doing a research report on the temperature difference of chlorine-containing ionic compounds melting ice. Scientists have been studying different salt compounds that will melt ice quickly in order to decide which will most efficiently melt icy roads in the winter. The temperature seems to play a large factor in which salt will melt the ice the quickest. Rock salts are effective down to temperatures of -9 degrees Celsius, which is the lowest the temperature can be before the salt turns the ice into slush instead of melting it all. The goal of this project is to discover which salts, which is a mineral, or in this case chlorine-containing compounds, are most effective at melting ice. The independent variable would be these compounds affecting the temperature change of solid H2O, which is the dependent variable. The experiment specifically looks for how these compounds affects the temperature change, applying to snowy roads in the winter as salts are used to melt the ice. Currently, the most common ice melting compound is NaCl, or table salt. Our predicted hypothesis states, if chlorine-containing ionic compounds have a higher molar mass, then they will have a greater effect on temperature because there is more mass to weaken the attraction between the water molecules. This hypothesis was deduced by examining existing experiments of this topic and calculating the molar mass of the compounds. A math model of this experiment would contain H2O energy that would begin to melt the ice. The averages of the trials could be graphed and compared to one another to discover which compound had the largest temperature difference.
The materials used in this experiment were ice, aluminum chloride, potassium chloride, magnesium chloride, sodium chloride, calcium chloride, 2 beakers, a smaller one and a bigger one, a balance, a temperature probe, a laptop capable of running Logger Pro, and a LabQuest. Step 1 was to start up Logger Pro and plug in the temperature probe into the laptop. Step 2, set temperature recording interval to 5 seconds. Measure out 50 grams of ice in a beaker using the balance, and then measure the temperature of ice with probe. After that, you pour the 5 grams of chlorine compound onto the ice. You place the probe in the beaker. You record temperature changes in ice with Logger Pro for 5 minutes. After that, you write down the data you have collected and clean your station.
The data is organized into 2 figures. On the left, you can see all of the compounds tested with both trials and their temperature change in degrees Celsius. On the right, the average temperature difference before the salt is poured on the ice compared to after 5 minutes has passed. These are just the averages graphed. The data suggests that the largest temperature difference was the trial of sodium chloride, and the least difference was magnesium chloride, making it the least effective. The data from the table was put into the graph with each compound using the mean of the 2 trials to be graphed. The graphs that flatline quicker show us that a phase change is occurring, which means that a compound is very effective at melting ice. Potassium chloride and sodium chloride each flatline before the halfway point of the trial. This shows that their temperature change happened very quickly, allowing for the ice to melt even faster. A possible reason that magnesium chloride had such a small temperature change could be because it is an endothermic ice melter. All of the data is based on the 5-minute time limit that the experiment requires.
Our original hypothesis was that if chlorine-containing ionic compounds have a higher atomic mass, then they will be effective at lowering the temperature and therefore melting the ice because there is more mass to weaken the attraction between molecules in the H2O bonds. Our hypothesis was supported by our results, as calcium chloride was the most effective chemical at melting the ice and had the largest atomic mass of the 5 compounds used. Our findings are supported by the fact that, according to the American Chemistry Council, typical road salt, the salt spread on ice to melt it during the winter time, is usually composed of calcium chloride and other chemicals. Some of the errors that occurred during this data collection portion of the experiment were dropping the chemical directly onto the probe, which raised the temperature recorded, letting the probe settle against the bottom of the beaker instead of staying in the ice, which lowered the temperature recorded. However, these errors did not affect the results of the experiment too much, as we still had potassium chloride, magnesium chloride, and calcium chloride as the most effective chlorine compounds, which is supported by previous findings from other projects done. The findings of our experiment are significant because future applications could be used in road salts to more effectively melt ice on roads during the wintertime.
Bill Nye the Science Guy.